Okay, good morning. Uh, so we start a new chapter today, and that is a very important chapter about algebra and equations. So let me, you are familiar actually with a lot of concepts, at least in the beginning, but let me just review them. So in algebra, um, so the cornerstone of mathematics is numbers. So whenever you have something, you have to you have numbers, and then you know arithmetic. So it means that you can add them, subtract them, multiply them, divide them, or whatever you have learned so far to do with them. But in algebra, the weakness of working only with numbers is that if you, for example, if I give you a square. Okay, and I give you the length of the side to be, for example, 5 and everything in centimeters. If I ask you what is the perimeter of this, or circumference, perimeter of this square, what you do, you actually take 5 and multiply it by 4, and then it becomes 25 centimeters. Yes? Sorry, 20. Yes, 20 centimeters. And then, of course, if I change the size to another number, you can redo the calculation and find the again perimeter of that one. But you have to redo it again. Okay? So, for example, if I change it to 6, then you will redo it again 4 times, I don't know, 6, and then it becomes 24 centimeters. It's nothing wrong about this. But if you want to do it all the time, by changing the number, if you want to do the calculation all over again, it becomes messy. In this case, the calculation is so simple and straightforward, so it doesn't matter. Every time you can just redo the calculation, okay? But now, the more effective way of doing it is actually, for example, say that, okay, if the length is just any number x is not a particular number, but that is important to know. X is actually an English letter X. In mathematics, I use X and I give it a name. I call it a variable. Variable means something that can vary. But at the end, I want you to understand that X is a name that we give to a typical number, but which number, it is not clear until we assign a number to that variable. So if I give you, instead of 4, 5 and 6, if I ask you to write a formula or an expression for the perimeter, then what you do, you say that 4 multiplied by this x is an expression that I write for this. Yes, for the perimeter of this shape. Then it means that if I give you 5, then you replace x with 5. If I give you that this is 6, you just take this one and put 6. So you have an expression which gives you the perimeter of this, whatever you choose for x. So this is actually a superior method, because if the calculations are messy or heavy, you do it only once. Of course, the price that you pay is that usually working with variables is a little bit harder than working with numbers. But at the end, what you get is a generic formula that you makes you actually free from doing it all the time. So you do it once, a little bit harder. What I'm saying is that because the novice students are more comfortable with working with numbers, because mainly you can use your calculator to put numbers, but you need a little bit more advanced application to be able to use algebraic expressions and put them there, okay? But the point is that if you actually be patient and learn the rules of algebra, at the end you will be more powerful if you just want to work with numbers. So if your calculation is a hard one, I would myself really prefer to do it algebraically once for all, and then whenever I want to calculate that quantity for some particular numbers, then I have my formula in front of myself, and I just replace the variables with the appropriate numbers and then do the calculation at the end once. Okay, another good point is that, for example, if you want to write a computer code, these days computers are actually doing a lot of things for us, making it easier. So if you want to, for example, do the calculations with a calculator, for example, if you ask the calculator to solve an equation for you, how the calculator knows the answer? Because someone has already done it algebraically and have written a code so that the calculator is following that code. And whenever you give the numbers to the calculator knows that in that code these numbers should be substituted for that particular values and give you the answer. So that is extremely important, that you learn how to work with letters rather than numbers. But one thing that I want you to keep in mind is that whatever letter we are working here, they are numbers. We are saying that when you see 4x, of course you know that when you learn English, you do not do not multiply the alphabet, this letter, English letter x by 4. Yes, you can just juxtapose them to make words. Yes, you do not multiply them or operate them. So that is important to realize. The variables that I am using here are representative of numbers. So x is a number. When x is a number, if this x is an English letter, it is meaningless to say multiply letter x by 4. But if x in my head represents a number, then it is completely understandable to what does it mean by multiplying 4 by x. But can I ask what the value of 4x is? No, at this stage, unless I give you what the value of x is. If I tell you x is 5, then I can ask you calculate this for x equals to 5. Then you replace x with 5 and then give me the answer 20. Yes? Okay. So I want you to understand, this one is called an algebraic expression. Yes, it is a number but written with the use of variables. And why we call it variable? Because you can change your mind and change the value assigned to those variables. Here you can choose 5, sometimes you can choose 6, so that's why it's called a variable. One thing that is important right away to understand is that I can have different variable names. Okay, so I can have x, and in the same problem I can have y. I want you to understand, if you choose different letters, okay, this means that the values that you can assign might be different or equal. For example, I can give you this algebraic expression. Yes? So this is addition between two letters. This means, according to this, these are numbers. I am adding those numbers. But can I calculate and go further? No, unless I give you the values for x and y. But can I say calculate the expression x plus y for x equals to 1, y equals to 2? Yes. Then what will be your answer? It will be 1 plus 2, it is 3. But can I say calculate this for x equals to 1 and y equals to 1? Again, yes. So I would calculate 1 plus 1, it is 2. So one thing that I want you to understand, even though I am using different letters, x and y, it doesn't mean that I am not allowed to choose the same value for them. Okay? So be careful about that. But these two might not be the same thing. So here, if I write x plus x, I cannot ask you to calculate this when the first x is 1, the second x is 3. This is meaningless. So this is the rule that you need to respect. When I ask you to calculate this, I can ask you to calculate this if x is 5, and what you do, you just put 5 for the first x and 5 for the second x. Okay, I cannot ask you to calculate this if the first x is 5 and the second x is 10. Okay, this is the convention we want you to understand. So if you really need the degree of freedom to have different numbers, you have to choose different letters. So when you choose different letters, it means that they might be equal, if you want to, or they could also be not equal. But if you use the same letter in the same expression, they have to be the same values. Yes? This is the first thing that I want you to know. Okay, so for example, something like this, 2x to the power of 2y plus 3x. This is an algebraic expression. Yes? So how many variables you see this in algebraic expression? 2 variables. This x appears here. This is x to power 2, which is meaningful. Why? Because I told you that x is a number, and whatever number you have, you're allowed to raise it to power 2. And then you are allowed to multiply it by another variable, which is a number multiplied by this number. It becomes a number at the end. In your head, this is just a number written in a little bit fancy way. Yes? And this is also a number. And then you are adding these two numbers. Yes? Yes? Is that clear? Okay. So this algebraic expression contains 2 variables in this case. So I can ask you to calculate the value of this if x is, say, for example, 2 and y is equal to, for example, 3. Yes? What you need to do, you need to go here and then replace every appearance of x with the value assigned to it, which becomes 2 to the power of 2, and then multiply by y. Here is 3, and then plus 3 times 2 again. Because x appears in 2 positions here, I have to replace all of them with 2, and I have to replace every appearance of y with 3, and then you, at the end, you get a number, and that number you should calculate. So then what happens? It becomes 4 times 2, 8, 24, and then I have plus 6, the answer becomes 30. Yes? Is that clear? So, and because this is also sometimes I see the students make mistake. When I say algebraic expression, what you need to expect to have something related to some number of variables. But remember, there are no equality signs there. Okay? So, this is an algebraic expression. For example, I cannot ask you solve the following algebraic expression. I can ask you, we'll see, I can ask you simplify this algebraic expression. It means that write this algebraic expression a little bit shorter or much shorter sometimes, but so that this is equal to the previous algebraic expression. Okay, can you tell me when do I say 2 algebraic expressions are equal? Because sometimes people say that, okay, if they look the same, they are equal. But this is not the good way, because, for example, I will come to you. For example, this algebraic expression and this algebraic expression, they look different. They are not identical. Everyone realize the difference between these 2 things that I have written here. But I would call these 2 algebraic expressions equal. Why? So no, if you not 100%. In mathematics you have to be very precise. It means that whatever I choose for x and calculate this, and I choose the same x and calculate this, they become always equal, regardless of what I choose for x. So remember, when I say that 2 algebraic expressions are equal, this doesn't necessarily mean they are identical in how they look. It means that whatever you assign for the variables to one of them, it becomes the same number if you assign the same numbers for the variables of the second one. So that is the obligation when we say 2 algebraic expressions are equivalent or equal. Okay, so remember, when I say an algebraic expression, so you need to expect something like this. For example, do you think this is an algebraic expression? This is also an algebraic expression. Okay, how many operations are being used here? Addition and division. Yeah, so that's an algebraic expression. But sometimes algebraic expressions are not good with some particular values. What do I mean by this? For example, here I can ask you to calculate this if x is 5. Then what do? You replace every appearance of x with 5, then you get 5 over 6, end of the story. But there is one number that I cannot ask to calculate this for that particular number. What that number is? For example, can I ask you to calculate this for 7? X7? Yes, 7 over 8. For 10, 10 over 11. There is one number that I cannot ask you to calculate that, yes? No, 0. If I put 0, what happens? The numerator becomes 0 divided by 0 plus 1. But everyone knows that 0 plus 1 is what? 1, the 0. By the way, I want to make sure that you understand. If I have a fraction whose numerator is 0, what the answer is? 0. Yes? So this is 0. That was a good idea. So, but there is one that I cannot ask you. So for 0, I was able to ask. What is the value of that expression for 0? It is 0. Yes? Minus 1, I cannot ask. If I ask you to calculate this for minus 1, what happens? The denominator becomes 0. So what you do, if I say x is equal to minus 1, what you need to do, you need to replace x with minus 1. Every appearance of x with minus 1, then you immediately be in trouble. Because you have minus 1, what is the value here? 0. And you know that minus 1 divided by 0, division by 0 is forbidden, so it's not defined. So, but whenever we talk about this, remember, even though I don't mention it, I mean x is not equal to minus 1 implicitly. So when I talk about this algebraic expression is, when I say this algebraic expression, I mean when this is meaningful. This is meaningful except one possibility, and that is x equals to minus 1. So whenever I talk about this algebraic expression, I want you to understand yourself that this is valid unless x is equal to minus 1. This is called the domain of the variable. Okay, so x over x plus 1 is, when I talk about this algebraic expression, what do I mean? I mean that implicitly you should assume that in the domain of applicability. So it means that when I talk about this algebraic expression, you need to understand I am talking about this algebraic expression except for the case x equals to minus 1. So x minus 1 is excluded from this algebraic expression. Yes? For example, can you just talk a little bit about this? Square root of x minus 4. This is also an algebraic expression. But do you think I am allowed to use any number for x that I want to? Do you remember the previous lessons? For example, can you give me, so let me give you x equals to 5. I can ask you to calculate this algebraic expression if x is equal to 5. What will be your answer? You need to replace every appearance of x with the value that I assign for you. Then it becomes what? Square root of 5 minus 4, and the answer is square root of 1, but everyone knows that what is the square root of 1? 1. Yes, square root of 1 is 1. But can I ask you to calculate this if x is 4? Let us check. I have to replace every appearance of x with 4, and then it becomes square root of 0. What is the square root of 0? 0. But now, if I ask you to calculate it for x equals to, for example, 2, then what you do, you write 2 minus 4, but then what happens? It becomes square root of minus 2. But we learned in the power lesson that this is not defined. There are no numbers, there are some complex numbers, but we will study them in Math 4. But for the time being, there are no real numbers, so that the second power of them is negative 2. Why is that? Because even if I have a negative number, when I raise it to power 2, it becomes positive. So this is meaningless. So again, when I talk about this algebraic expression, you need to understand I am talking about this whenever it is meaningful. Can you tell me what are the values for which this is meaningful? Exactly. So how do you write it? You say that x is greater than or equal to 4. So this means that if I give you a number which satisfies this condition, then it is meaningful. But if I give you a number which does not satisfy this condition, then it is meaningless. So I want you to know, I will not emphasize on this that much, but whenever I write this algebraic expression, I want you to understand that this algebraic, I mean whenever it is meaningful. Yes? Is that clear? So for example, if I talk about 2x plus 3 divided by x to the power of 2 minus 4. So when I say this is an algebraic expression, by the way, let me write another thing in front of it. For example, 2x minus 5. This is an algebraic expression. Yes, in how many variables? In one variable. How many exceptions are there for my variable? I mean, this is always meaningful except some cases or some one case. I want you to tell me which cases. Yes?
X has to be bigger than 2.
Not bigger than 2. You are being confused with the square one. Think a little bit more. Which number or numbers I am not allowed to put in instead of all x's? 2 is definitely I am not allowed to put. You are right. Why? Because if I put 2, what happens in my denominator? 2 to the power of 2, 4 minus 4 is 0, and division by 0 is forbidden. Of course, 2 doesn't have any problems here. 2 doesn't have any problems here. But the only problem is that I have 2 here, which is problematic because I'm not allowed to divide by. So 2 is one of the numbers that I am not allowed to put instead of x. But in this case, there is one more. What is the other number that I am not allowed to put for x? Minus 2. Yes? Because am I allowed to? So if I put x, if I instead of x I put minus 2, what will happen? I know that this is possible, forget about this. This is what I am writing is the denominator. Then I know that minus 2 to power 2 means minus 2 multiplied by itself, which is 4. And then minus 4 is again 0. So whenever you see this expression, even if you don't see this in explicitly in the problem, you need to understand they mean that x is not equal to plus or minus 2. Okay, so you are not allowed to use this. This cannot happen in numbers because with numbers, if they are numbers, you can see that this is not 0. Okay, but here be careful when you start working with x2 minus 4. It is completely okay for this except 2 very special cases. So whenever you see this algebraic expression, it means that you need to understand yourself that x is not allowed to be 2 or minus 2. But except these 2 numbers, everything is okay. Is that clear? Okay. So for example, do you think I have a limitation for this if I have to do this? If I write this, but instead of putting it in the denominator, I put it here, and then I write 2x minus 5. Yes? Do you think I have any exceptions for the variable that I have for the value of my variable here? How do you know that? There is no, because the operations involved, what are the operations involved? Multiplication, addition, the power, and then multiplication, I don't know, multiplication, addition, subtraction. These operations doesn't have any limitations. There are 2 operations with limitations. Can you tell me, just review them? Yes, one of them is not only a square root. Division is one of them. So what is the limitation for division? The denominator cannot be 0. That's one. But for a square root, you told me that's correct. But not only square roots. No, even roots. 4th roots, 6th root. You remember? We had this in the... So if I write this, it's even. So if I have, I mean 2, which we don't write, this one, all the even roots have some limitations. I am not allowed to put negative numbers below them. Is that clear? Yes or no? So for example, can you tell me when this is meaningful? X minus 1, and then I would write plus the 4th root of 2 minus x. It's a little bit tricky. I don't want to go through this too much, but I want you to understand this is an algebraic expression in one variable. The variable name is x. By the way, usually we use x, so if you don't mind, let me change the name of the letter a this time. It doesn't matter. Do you think this algebraic expression is always meaningful or sometimes not? If not, I want you to discuss about this. When do you think this algebraic expression is meaningful? How many operations are involved here? Yes, subtraction here and there. addition here, so 2, so, and then we have the second root and the fourth root, so 4, yes? Subtraction, addition, the second root and the fourth root. Subtraction, addition, they don't have any limitations at all, so I don't need to be worried about them. But what should I be worried about is the second root and the fourth root. Okay? For the first one to make sense, I have to respect the values for a. So how? Yes? So it means that a from this one should be what? Greater than or equal to 1. Do you think this is the only limitation? Do you think if I respect this, everything is fine? Why not? Because if I respect this, I might make trouble for the second one. For example, assume that you just write this and then you choose 10. 10 is okay for this one. It gives you a square root of 9, which is meaningful. But if you put 10 there, 2 minus 10 is minus 8, which is negative. It's not acceptable. Okay, so I cannot just do trial and error. I want you to understand, okay, so this is good, but not enough. Can you tell me what would be the rule? On the one hand, because this should make sense, A should fulfill this condition. But this only guarantees this part to be right. I have to also guarantee this one to be right. So can you tell me now what the value of A should be there? Yes? Less than 2, yes. So on the one hand, A should be equal to or greater than 1 to make this right. On the other hand, A shouldn't be that big, because if this is so big, then suddenly this becomes negative and then I am trouble again. So I would say that A should be, on the other hand, less than or equal to 2. So on the one hand, A should be greater than or equal to 1, and this is extremely important, by the way, in the future. We have to write and A should be less than or equal to 2. Yes? So in principle, if you want to imagine that, so here is 1. Let me exaggerate a little bit. Here is 2. A can start from here and goes to the right if A is greater than or equal to 1. But on the other hand, A shouldn't exceed than 2, so it should be less than 2. So it means that the numbers here are acceptable. Yes? Usually, instead of writing so much, I don't know, do you remember how to write it? Might be in high school. So we have this symbol. Yes? This means that A is between 1 and 2, including 1 and 2. So if I ask you, what is the domain of this algebraic expression? You will tell me that the domain is every number between 1 and 2, including 1 and 2. How many numbers are there? No, that's why I have some experience to ask this. Yes, infinitely many. Yes, because 1.1, 1.2, all the numbers between 1 and 2. There are infinitely many numbers that you can choose, but they are limited in values. They are all sandwiched here. They are all pressed, squeezed in this very small thing. So remember that. This is something we will not discuss about this that much. I will until we reach to the topic of functions. But for the time being, remember, whenever you write algebraic expression, it means in its own domain. Algebraic expression, if it is, I am working in its own domain. Okay, so let me just calculate, give you some examples. Okay, so for example, evaluate this expression, x to the 4 plus x to the 2 plus 1 for x equals to square root of 2. Yes? So how should I how should I solve the problem? This is easy. When you say evaluate, it means that I have given you an algebraic expression, and I am asking you to evaluate the value of that algebraic expression for a particular value that I have assigned here, x equals to square root of 2. So how should I you answer this question. So what you need to do, the question mark that asked in the problem means that go to your algebraic expression, see how many places x appear. Here in this case 2 cases. Every appearance of x should be replaced by square root of 2. So this means that square root of 2 to the power of 4 and then plus square root of 2 to the power of 2 plus 1. So what is the answer here? So this one is easy, hopefully. Let me copy and paste the 1 part, which is simple. But the square root of 2 to power 2 is 2, yes? But then what happens for a square root of 2 to power 4? 2 to the power of 2, which is 4. So the answer to this is how much? Is 7. Yes? So this is very simple. So let me give you 2 algebraic expressions. Let me give you a minus b to power 3. And let me give you another algebraic expression, a to the 3 minus 3a squared b plus 3ab squared minus b to the power of 3. So I have this and I have this. I want to calculate each one of them for some particular values for a and b. Say, for example, let a to be 3 and b to be 2. Okay? I want to calculate this one for these values to see what the number is. I want to calculate this expression for these 2 numbers and to see what the value is. Yes? So let us just do that together. So the first question mark here, so I would say that a minus b to power 3 is equal to. Instead of a, I put 3. Yes? So this becomes 3 minus, instead of b, I put 2. And then I calculate this. So what is the answer? It's 1 to the power of 3, and then the answer is 1. And then for the next one, I have a to the 3 minus 3a squared b plus 3ab squared minus b to the power of 3. Every appearance of a should be replaced with a value, and every appearance of b should be substituted with 2. So then let us calculate. So this becomes 3 to the power of 3 because a appears here, here, and there. And then I will have minus 3 times 3 to the power of 2. This 3 is in the algebraic expression. Instead of a, I replace 3 again. I put 3 again, and then I will have b here. b is 2. So this becomes multiplied by 2. Then I go to the next step. 3 is again there. Instead of a, I put 3. And instead of b, I put 2. Yes? And then finally, minus b to power 3. So it is minus 2 to power 3. And we have to calculate this. Yes? This is not to power 3. Yes? No, even for a square root, it doesn't. Which one you mean? No, a square rule is not. I don't know if we haven't talked about the square rule, but if you already know from your previous studies, that rule only works when it is 2. It doesn't work when it is 3. Yes? But for 3, we have exactly this. Okay? Anyway, let us calculate this. So then what happens? This is 27. I hope that you agree. 3 times 3 times 3. And what is this value? 3 times 9 is 27 times 2, 54. It's minus 54. And then 3 times 3, 9 times 4, which is 36. Minus 2 to power 3 is 8. And then I have to calculate them. So 27 minus 54 is minus 27. Plus that one is 9. Minus 8 is 1. Okay? So you see the values are the same. Can I conclude that these two algebraic expressions are equal right now?
If the variable.
If the variables, but in total. Can I write something like this based on this observation? Can I say a minus b to the power of 3 is equal to this? Okay, can I just jump into this conclusion and say that this is equal to that? No, so what you are saying is that for the values of 3 and 2, the left-hand side is equal to the right-hand side. But my question is that, are these two algebraic expressions equal? Do you remember what I told you about 2x plus 1? Do you remember? And 2x plus 2. We say that they are equal because whatever you choose for x and put it here will give you the same answer if you put the same value of x here. Whatever you choose. Here, what I have chosen one particular value, 3 for A and 2 for B. Yes, you are right. For this particular case, I was able to convince myself the value of this and the value of that are the same. But I want you to understand, right now, jumping to this conclusion that these two algebraic expressions are equal might not be true. Okay? Because might be you can find other numbers so that when you calculate the left-hand side, it does not match with what if you put it on the right-hand side. Do you understand what I mean? So when you see this in algebra, it's a very general idea. So I want you to understand, in algebra, when you see this equality between algebraic expressions, it means it is true if you can convince yourself whatever you choose for A and B, the left and right become equal. Is that clear? But this is not what we have done in this process yet. We have just done it for one particular case for A and one particular case for B. Yes? Is that clear? So for example, if I want to give you a more tangible question. So for example, x squared plus x plus 1, and then I can give you x plus 1. If I choose x to be 0 and calculate the left-hand side, the answer becomes 1. And if I choose 0 here, the answer also becomes 1. Okay, but because this one is 1 and 1 for 0, if you just jump into the conclusion that these two are equal, this is not a correct logic. This is not in general true. Yes? So if someone tells you, are these two equal? By the way, this is also wrong to say that no, they don't look similar, so they are not equal. I want you to understand. So you cannot say that, okay, this is completely different in writing. The way that I write the right-hand side is really different from what I have written on the left, so they are not equal. That is also wrong. Yes? For example, it turns out that this is indeed true. This is one of the formulas in algebra. Might be we study this later, because in up to second power you have it in the book, but for the third power you don't have it. Later you will learn that this is indeed true, but this is not the proof. Yes?
So you're saying is that they're only equal to each other if independently of what number
Mm-hmm.
like
You choose for, yeah?
they always become the same.
They come the same.
Okay.
So that is the power of algebra. So when you say that this expression, by the way, this is a little bit of confusion. By the way, it's not confusing. For example, if I give you this number and I give you this number, they don't look similar. I mean, they are not identical. Here I have used 20 and 4 to construct this number. Here I have used 10 and 2 to construct this number. But then we know that these two numbers, even though they don't look the same, they are exactly equal. Both of them are equal to 5. In numbers, it is easier. But in algebra, even if it works for one choice, there is no guarantee it will work for all cases. So I want you to understand these two important points. If I ask you to show this is true, If you just say that, okay, let give me an example, it is not. It is good to confirm yourself to get the motivation. Is it true or false? Okay, but if you give me even millions of examples that it works and jump to the conclusion, okay, after 1 million examples, definitely it will work for everything. This is the illogic. I want you to understand that. So in algebra, if you want to prove this, you have to have a different way of reasoning so that you can convince yourselves that this is true independent of my choices for A and B. And then you cannot do this by case checking, because how many cases are there in general? Infinitely many. And even if you have a supercomputer, that's not good enough to actually to check all the cases. Because for checking infinitely many cases, you have to wait infinitely long time. Yes? So that is not possible. I want you to understand the logic, okay? If I ask you to show that this is true, this algebraic equality is true, this equality between algebraic expressions is true, you need to find a way to show me this is true independent of the values that I choose for A and B. We will come to this later, okay, how we can confirm that. Another thing that I want you to understand is that if I ask you, are they equal? If you say because they don't look similar, they are not equal, that is also not true. Okay? Because later we will see that even though these two are not the same, they don't look the same at all, but they are really equal. It means that whatever you choose for A and B here and choose the same values here, they always match. Okay? So by algebraic expression, don't judge based on how they look. Okay? And then if you want to show that this is true, don't consider case by case consideration. You have to have a good reasoning for that. Okay. So for example, let me give you some examples. So this formula is the formula that we will study in Math 2C, but let me just write the formula. This is an algebraic expression with 3 letters, 3 variables, minus b plus square root of b squared minus 4ac. You might say, why I am writing this algebraic expression all of a sudden? The reason is that this formula becomes a very important formula when we study in Math 2C the quadratic equations. But for the time being, let me ask you to evaluate this. If I give you, for example, a to be 1 and b to be 8 and c to be 7. Okay, so we want to, so the question is this: evaluate this algebraic expression which contains some operations and 3 variables a, b, and c for these values of a, b, and c. Okay, so let me just pause recording so that you can also see how it works. Okay, so what the answer is, the first thing, we have to calculate this. I think what you said is correct. So minus b is given to be 8, so minus b becomes minus 8. And then I have plus square root of, by the way, when I say do this, I mean every appearance of b should be replaced by 8. So here and there. And every appearance of a should be replaced by 1. So let me just write it 4 times 1. And every appearance of c should be replaced by 7. But I also have another a here, so 2 times 1. And then what I have to do is to calculate this. But you need to know the priority of operations as we did before, so we go and calculate this part here, because if I want to do this addition, I need to know the number on the left, which I know it's minus 8. And then I have to know the number on the right. So I have to calculate this one. Yes. So it becomes minus 8 plus square root of. So be patient here. 8 to power 2 should be done first, because whenever I want to do subtraction, I need to know the numbers on the sides. So 8 to power 2 is 8 times 8, which is 64. And 4 times 1 times 7 is 28. And then we are supposed to subtract them. And then divide it by 2 times 1. And then we continue one more step. So I have to copy and paste this one, but I have to calculate this one first. So this becomes plus a square root of 64 minus 28. How much is that? 36. And then divided by 2. And then 36 is a good number, by the way. So it's a square root of 36 is 6. Should I write plus or minus 6 or just 6? Plus 6, remember. If I ask you how many numbers are there whose second power is 36, then you say 6 and minus 6. But if I write square root of 6, it's always the positive one by the convention, if you remember. And then minus 8 plus 6 is how much? Negative 2 divided by 2. So the answer is not 1. The answer is negative 1. Yes? Okay. So this is also... I want to just give you an example here. That's a good formula. Of course, the proof of this formula is hard. You might haven't seen it before. So the formula is a little bit complicated and famous. Let me talk a little bit about this. So, by the way, so do you remember the formula for the area of a triangle from your studies, previous studies? So what is, if you want to find the area of a triangle, what do you do? Yes? Area of a triangle. Triangle, yes? So how do you calculate the area of a triangle? Yes? 2. Yes, that is the normal one. But to be honest, this is not a very effective, because whenever you have a triangle, what seems immediately comes to your eyes are the length of sides, not the height. Yes? By the way, for example, if you have a piece of land in the form of a triangle, it is not that easy to measure the height precisely. Yes? Because first of all, if I just draw a random line here, this is not guaranteed to this angle should be 90. I mean that if I want to find the height, I have to be really careful in how to draw that height, because that angle should be precisely 90 degrees. Of course, if I find a way to find the real height, so let me call the height h, and let me call this base a, and of course the surface area s, then that is correct. You can write 1/2 of the height times the base. By the way, whenever you write this, I hope that you understand, this is algebra. Because S means a number, A and H are numbers, so how many variables are indeed in this formula? 3 variables, S, A, and H. This tells you that by this formula, if you give me the values of A and H, then I can give you the height. So this is already algebra, so you are using already algebra. Otherwise, you need to solve the problem case by case. If I give you a triangle with particular values of A and H, then you have to find the formula for the area of that and then redo it again if I change my numbers. But when you write something like this is a very valuable thing. It's powerful. So it doesn't matter which triangle. If I change my triangle, of course I will affect the A and value of H, but then I put them in this formula, I find S. So it's already the power of algebra. Okay, but I want you to understand, even though this is a very simple fact, and of course that's 100% correct, we can find the area of the triangle using this formula, but this is not the most natural one. Which one is easier to measure? The length of the side is easier, or the height is easier? The length, because you take the meter tape and then measure the length, as simple as that. You really don't need to be worried about the height. And that was actually an ancient problem. If you want to find the area of a triangle, the natural thing comes to mind is that, is there any formula that I can use to calculate the area if you give me the lengths of each sides? It's more, by the way, it's more natural, isn't it? So if you have a shape, I give you a triangle, and then you have a ruler, you can immediately measure the length of the sides. Yes? But if I give you a triangle, ruler is not enough if you want to use this formula. You need another tool, which is called protractor, measuring angles, okay? So you need to have that tool to measure the angle as well, and then, of course, a ruler. So, this formula that I want to write for you, this is Heron's formula. It was an ancient, actually, mathematician. He invented a formula for the area of a, not invented, he discovered, or actually he found a formula for the area of a triangle expressed in terms of the lengths of sides rather than the height. The formula is complicated, but let me just write it for you here. So S, the surface area, turns out to be, if I have the triangle like this, ABC. By the way, it is common in geometry. If the letter here is A, the length of the opposite side is denoted by lowercase letter. If this is B, we denote this length by little b, and this is C, we denote this by little c. Assume that someone has given you these numbers, and they ask you to find the height. They ask you to find the area. It is not, by the way, simple at all. Because, of course, you have the base. But if you want to use this formula, you have to measure the height as well. Okay? But that it's not that easy. But that person actually, using the power of algebra, calculated the height if I give you these numbers. And the formula turns out to be a little bit complicated. Let me write the formula here for you. So this is S, little s. To be honest, let me take it to be P. Don't confuse it with this one. P minus A, P minus B, P minus C. And if you ask me what P is, I would say P is half of the circumference. Okay? And how he actually came up with this formula is the power of algebra. Yes? It's a, I would say a little bit, for your grades, a really complicated calculation that gave rise to this formula. But understanding the formula is not hard. Yes? For example, if I give you a triangle so that the sides are, so everything, let us express it in, for example, centimeters, and then let me write it 2, let me make it 3 and 4, and say, for example, 5. Yeah, it's not a good number. Why is not? Because 3, 4, and 5, calculating the area of this triangle is super simple. Why this is very simple, calculate the area of this triangle? Yes?
You can add 3, 5, and 4 and divide them.
No. You don't need this formula for this very case. Can you tell me why? Because these numbers are very famous numbers in geometry. They are Pythagorean numbers. Because 3 to power 2 is 9, 4 to power 2 is 16. If you add 9 to 16, it becomes 25, which is this 1 to power 2. So this means that this is indeed a right angle triangle. So if I draw a triangle with these sides, definitely it is a right angle triangle. And if I ask you what is the area, in a matter of seconds you should be able to tell me the area. What's the area? What? No? No? So we will work on geometry as well, because algebra and geometry are the main subjects in this book. So we have to start working with them as well. No. So because you know that, by the way, what do you mean by base? It doesn't matter how you put this on the ground, yes? You can rotate it and put it from this base, yes? Yes? So if I cannot draw precisely things, so assume that you rotate it. Oh, the other way around. So you rotate it and then put it in this way. So 3 goes here, and then 4 goes there, and then this becomes 5. So what's the area? Now this will play the role of your base. This will play the role of your height. And then height times base divided by 2 is 6. So that was my bad. If I give you these numbers, you really don't need so complicated formula. It's easy to understand that the area should be 6. But to be honest, it doesn't matter. It doesn't hurt if I calculate using Heron's formula. Okay? So let us calculate this using Heron's formula. How should I use that? This is an algebraic expression. So S is equal to this formula, but you might ask what P is. P is also given in the formula itself. P is this one. So the first thing that you need to do is to calculate P yourself. So what do? you write P is equal to A. One of them is A. For example, this is A, this is B, this is C. So A is 5 plus B is 4 plus C is 3 divided by 2. What's the answer? Yes, 6. So P is 6. And then I go back to the Heron's formula for S. Becomes equal to every appearance of P should be replaced by 6. Yes? And then instead of A, I put 5. Instead of B, I put 4. Instead of C, I put 3. And then I calculate this again. This number is 1. This number is 2. This number is 3. 6 times 1 times 2, 12, times 3, 36. And the square root of 36 is 6. Of course, in this very particular case, no one will do this. This is a little bit of suffering here, yes? We have to calculate a lot. But if I change these numbers to any type of numbers that you can construct a triangle with those numbers, then I cannot have that shortcut. I have to calculate it using the Heron's formula. So here I just want to you see that formulas might be a little bit more complicated. But this is very good because you can write a code if you learn how to put formulas in computers. And then what you need to know is to know the numbers. As far as you put the numbers in your code and then press the execute button, you will get the S. That you couldn't do it if you don't know algebra. Because if you don't know algebra, you have to do case by case. Yes? Any questions? Okay, so I think now we stop, but later what will be the topic of the lesson? Here I have just introduced what an algebraic expression is. It becomes useless if we don't know how to add algebraic expressions, how to subtract them, multiply them. So we need to learn how to do operations with algebraic expressions, which is the main topic of algebra. So if someone asks you what algebra is to do arithmetics with arithmetics of algebraic expressions. So you should know how to do that. Yes? It's extremely important, two topics, algebra and geometry for this course, they are really essential. Any questions? Okay, thank you.